Sorry, and I think that you must just have an open mind that this is not traditional monitoring or metering. This is more IoT based metering. So yeah, so if you've got any questions, just type them in or just hold them till end, and I'll do my best to answer everything. Okay. Let me just get that. So a little bit about Smappee. Smappee is a Belgian company, but we have got we trade globally. So the actual product, the hardware, works on any and all electrical systems worldwide, whether it be 50 hertz, 60 hertz, whatever. And we've got multiple offices all over the world. We have a team of really experienced energy professionals with over 100 years of experience combined. And we've actually won quite a lot of awards on our product, of design awards and functionality awards, especially in Europe. The other thing we're very proud of is that we do everything ourselves. So we produce everything ourselves, hardware, software, the whole lot is done in-house. We don't outsource anything. So we've got full control of the whole hardware and software processes. A little bit about me. I've been in energy management and utility metering for about 15 years now. I was with Honeywell Ulster. You probably know it. And I started with Smappee 3 years ago, and I look after Asia, Oceania, Middle East, and Africa. So I've got a fairly big area, and I've got a very interesting area because a lot of the area that I do are the emerging markets where people are looking to save energy from a financial point of view. And I always think of it as, what is the motivation? Is it consistency of supply, or is it to save money? And some of the markets are about consistency of supply. They're not actually about saving money. Yes, it is a factor, but I think the first thing that people want is consistency of supply. And I'm based in South Africa, and at the moment we've got load shedding or rolling blackouts, or whatever you want to call them, that every single day we are without power for a certain amount of time, because we have just not got the production. Our consumption of production is just way out. We just can't produce enough power for the country. And so one of the big challenges Africa's got is consistency of supply. The Middle East might be slightly different, but there are definitely places in the Middle East where consistency of supply is also a bit of a challenge. So why do people want energy management? I mean, you've got to start somewhere, and obviously measurement is the place to start. And energy prices and consumption are increasing massively. We are a very energy hungry world, but we have got limited supply, and infrastructure is not increasing at the rate of the actual consumption. So based on that, there's a big rise in renewable energies, where obviously due to climate issues, coal-fired power stations and nuclear power are not always, people not always want to increase that type of infrastructure. So there's a massive rise in renewable energy. And with this, there's obviously the need for a smart grid, where you can control things remotely. And with that electrification, where you've got limited power and energy available, and how do you actually use that to the best ability? So those are sort of the market trends out there, and why people are looking at energy management. One of the challenges is we don't know where the energy is going. So yes, people are metered for a revenue collection, but if you look on the distribution networks, the utilities don't understand actually where the energy is going. The biggest challenge is if you are producing renewable energy, you must use 100% of that renewable energy. If you've got a 1 megawatt plant, it's no good only pulling 500 kVA. It's just such a waste of money that you've put that infrastructure in and you're not using it. There's a massive imbalance of usage compared to obviously production, as I mentioned earlier. And then the electrical infrastructures are growing in complexity with all the new product out there, and the ability to shift energy around and the different types of energy that are being produced. So there's definitely a growing complexity in the electrical infrastructures. Sorry, let me just go to the next one. So the current energy management hardware and software actually doesn't cover all this. So there's a lot of insufficient energy data. There's very little control over where your energy is coming from and where you want it to go to. A lot of the traditional product is not future-proof. So if you have to upgrade your monitoring system, you've actually got to replace hardware. And the installations are very, very complex and very time-consuming. So what we looked at, Smappee, is a system that is user-friendly, small, easy to install, plug and play, connected, an IoT device, which is permanent connectivity, and very, very easy to commission. And from a cost of ownership point of view, it is actually very, very, it's got a very low cost of ownership. So from the Smappee devices, we get actionable energy data, in-depth actionable energy data. And this data comes from current transformers. So we measure with current transformers. One of the unique features of Smappee is that we can get 28 current transformers or Rogowski coils on one device, which equates to 9 three-phase supplies, or 28 single-phase supplies, or a combination of either or, as long as there are not more than 28 current clamps or Rogowski coils on the Smappee. And we can measure from 100 milliamps up to 10,000 amps with the current clamps or Rogowski coils. We have got a MRD device, an MRD certified 100 amp meter as well, which we can measure with. And we take, it's got no onboard storage or anything, but what we do is we take that device and we make it into a smart meter. We have got a smart plug which can switch and measures. So you can sub-meter anything that's 16 amps or less. So it's an ideal measurement device for appliances or different loads in an office environment or a home. So it's specifically aimed at that sort of market, 16 amps or less. And we also measure using a patented norm. So if you all know what Shazam is, it picks up the song automatically. The norm, which is called non-intrusive load measurement, picks up the electrical signature of different appliances without physically having to put a current transformer around them. And over time, it learns. And it gives you a lower accuracy, but it does allow you to look at what are your energy guzzlers within a home. So it can pick up appliances like your refrigerator, your coffee machine, your tumble dryer, dishwasher, washing machine, those type. There are about 12 or 14 different appliances that it picks up automatically. The longer that it's in, the more accurate it gets, and it learns over time. And it'll give you an indication of what your energy guzzlers are in a home. And the last way we gather data is we've got an input module, which we can add a gas and water meter or paraffin or fuel meter, or even a third-party electricity meter, where we can pick up the readings via a pulse output into that pulse input. And that gives you very, very accurate water consumption or anything from a flow meter. We then, based on this data, based on the measurement, we obviously then give you actionable data. So we've got an app which probably most of our clients use. It's very, very user-friendly. You've always got it. It's on your phone. You can do your smart home control or your smart building control on the app. And it can actually, you can even add your branding in that on the app. So your clients will then go and see who's supplying the Smappee. We do a dashboard as well, where we get in-depth analysis. You can compare multiple sites, you can download your data, and there again, you can have the your company support details on the dashboard. If you want to pull the data into a third-party energy management platform or even into a BMS system, we can do it via API. So we do software as a service through an API, and we can even do it through Modbus TCP. So it's also then compatible with any SCADA system or building management system. And the API data comes in two formats. I'll get to that in a second. It's actually been proven that if you have got live data, you can get about a greater than a 12% extra saving over if you are only collecting historical data. So one of the big things that our clients like is that we provide live data. And when I mean live data, I mean 1 second data. So you can actually look at your building, you can look at your factory, you can look at your machinery or your home, and you can see what are you consuming now. And that is a really big value add from Smappee's point of view. So it's live and historical data that we do supply. We've got a couple of, with regards to the data, we've got a couple of end user licenses. So we've got the standard end user license where you get access to all the electrical parameters on the dashboard and the app. And our big value add there is we actually do not charge for that license. So the data is free for the life of the Smappee. And the life of the Smappee is roughly 10 years lifespan. So the end user license is free. If you are looking for an API license, we do that as a software as a service. So the API license is historical data only. We also then provide real-time data and historical data through API and MQTT broker. And then we've got 2 power quality licenses. The first power quality license gives you minimum and maximum values of the voltage and the current. So you can then go and have a look at if there are any issues in your electrical system. And the second power quality XL license gives you the minimum maximum of the voltage and the current, and it gives you harmonics. So it will give you live harmonics, historical harmonics, and statistical harmonics up to the 19th harmonic on the voltage and the current. So there's a huge amount of data available that you can process. So on the monitoring and the actual energy management side, where you want to go and actually manage your energy, we've got a couple of bits of hardware that you go and control your energy flows with, or your breakers or your contactors, whatever you want to do. We have an output module, which is a 5 amp output, which you can connect through any contactor, motorized breaker, shunt trip, and you can switch any contactor on and off. So you can basically shed any load or switch any load on, as long as it goes through a contactor. So we are connected into the control signal of the contactor. I mentioned earlier the Smappee switch measures, but obviously it switches as well. So it can switch up to 16 amps, and it can control any appliance that is 16 amps or less. So it's a much more of a home or commercial sort of office type product, whereas the output module would be more of an industrial, more robust product for big commercial buildings, HVAC systems, or motors if you wanted to switch, or things like that. So, and then we've also just launched our electric vehicle chargers, which essentially is a contactor as well. And we have then allowed us to go using the Smappee to go and then do full overload protection, self-consumption, dynamic load management on the electric vehicle chargers as well. So it's a contactor in an electric vehicle charger, but we've made it into a smart device. So you can essentially go and then choose what you want to switch based on what criteria. So the automations are set up on the app and with smart devices. Obviously, you load the control modules or the Smappee switch to switch your appliances remotely. And there is another way as well of doing this in a sort of more of a home environment. We do integrate with Apple HomeKit, Google Assistant, and Home Assistant, and IFTTT. So you can then go and integrate this into a smart home environment where you want to go and do automations in your home. Probably 80% of our market is more in commercial industrial, but we do quite a lot in homes as well. But it's more of the high-end homes where the guys have got rooftop PV and electric vehicle, and they want to then control the energy flows in their home because maybe their breaker is only 50 amps, but they want to charge their vehicle, which is 32 amps, but they only want to charge their vehicle when they've got solar production. So that's when they generally incorporate into a home automation system. But you can also do that, obviously, in an industrial commercial environment through the automations and the control modules. So there's multiple automations. So you can essentially trigger any device based on active energy use, your kilowatt usage, an activity in a building, activity of an appliance or another load, location. So when I drive away from a building or when I drive to a building, I can switch things on and off. We've got solar optimization. So if you've got solar panels on the roof, we actually look at the historical data and we look at the predicted solar radiation weather data going forward, and we can then predict how much solar we believe that you will have available at a certain time in order then to switch something on. So if you only want to charge your vehicle, or you only want to run your HVAC system or your ACs when you've got excess solar, we can do that. So you can say, when I've got 10 kilowatts of excess solar available, then go and switch this load on. Or if my solar drops below this level, then go and switch this off. So essentially, our big aim when it comes to renewable energy is that whatever you're producing, you should be using. Don't put 10 kilowatts of solar in and then only use 5 kilowatts. If you're producing 10 kilowatts, use the 10 kilowatts. Otherwise, it's a real waste of money. So your production and your consumption graph should try to follow each other as best as possible. Obviously, we can do it based on a time schedule as well. We can do it based on import or export energy. And we can even do it based on a device state. So if you've got a diesel generator, you can say when the generator switches off or switches on, then I want to switch this off. And that's just done through the input and output modules. Very, very, very simple to do. We've also, as I mentioned earlier, we do quite a lot of third-party integrations. As I mentioned, Apple HomeKit, Google Assistant, if this, then that, home automation systems. We also do integration into building energy management systems and SCADA systems through Modbus TCP. And then we can obviously do the integration into other third-party energy systems using the API and the MQTT broker. So there's a huge amount, there's a lot of ways of integrating into existing systems. Okay, the reason why we chose the Modbus protocol, it's pretty generic, and it's a very commonly used electrical protocol for collecting energy data, and it's very easy to integrate. I've got the Modbus registers, and as I said, we do Modbus TCP, which is pretty simple. The beauty about that is you would get the access to the data on the app and the dashboard, and you can have access to the data on your SCADA system or your building energy management system. Okay. And you can do pretty much all the controls, the load balancing, and the switching through the Modbus protocol as well. huge plus is future-proof. We don't want people to install hardware and then have to take the hardware out when a new feature is launched. So, sorry, let me just go back. So we do over-the-air updates, we do firmware updates, where you can plug and play, you can keep product, you can take product out, you can add it in. You don't have to physically sort of, it's everything just plug and play with an RJ10 clip. The only intrusive installation in this whole system is your voltage. So you obviously have to connect the voltages, because that's where your voltage measurement, and it powers up the system, but everything else is just clip in or clip on. So it's a very unintrusive installation, and we do roughly 10 to 12 firmware updates every year. So if there's a new feature added, or new data, or new access to different data, we would then do it automatically. And most of the clients don't even know that the firmware update's been done. They will just maybe open the dashboard in the app, and they will see something new on the dashboard in the app. And that's very, very good when it comes to a future-proof product. We don't want you to have to uninstall this Smappee Powerbox because there's a new Powerbox. We'd rather just push a firmware update to the Powerbox. So on the actual hardware, I'm just going to briefly go through on the data measurement. We've got current transformers, we've got Rogowski coils, we've got a solid core 50 amp CT. I've mentioned the input module where you can counter pulse. The input module can also pick up a state of a device. So is the device on? Is it off? Is it high? Is it low? Is it open? Even a door. Is a door open? Is a door closed? We have got a residential device which counts a pulse from a gas or water meter. It's got two inputs, and it'll give you leak detection. It'll give you the temperature, and not the temperature of the water, the temperature, the ambient temperature, and the humidity. And then we have got a 100 amp Smappee MRD DIN rail meter, which connects into the Smappee system as well. Our main data collector from the voltages is the Smappee Powerbox. That's where your voltages go in, and that powers up the entire system. So there's only one voltage connection, and you can do single phase, three phase, even dual phase. You can do three phase star or three phase delta connection. And as I mentioned, it's a 50 or 60 hertz system. The brains of the system, we've got a couple of gateways. These connect to the Smappee cloud. We've got a Wi-Fi connect, which is by its name, Wi-Fi. It connects by Wi-Fi only. We do the Smappee Connect, which you can put a LAN cable into it, a 4G router, or you can connect via Wi-Fi. And then we've got the Smappee Genius, which allows you to do all the automations and controls. And that it's got Wi-Fi in. You can put a 4G dongle into it, a 4G router, or a LAN connection into it. So that allows you to do the control functionality, where the Smappee Connect and the Wi-Fi Connect will give you the data only. And then I've been through the controls. We've got the switch, the output module, and we've got the EV line. So we do 3 different types of EV chargers: home charger, a business charger, and then we do a public charger. Actually 4, sorry. We do a public charger, and we do a DC fast charger as well. A lot of my clients don't know what they want to control. So as you know, you can't manage what you're not measuring. Old cliched saying, but it's very, very pertinent. So you have to do the measurement first. And here again, you can, with the Smappee, you can measure, you can put the communication module in, and then at a later stage, if you want, you can go and add the control. So it's a very, very easy system to add. I would never recommend you just go and do the control straight out. You need to have a month or 2 of measurement first to understand what your system's actually doing. And as I mentioned earlier, there are 28 current transformers. So what's really nice about the Smappee, you can measure your main incomer, you can measure your solar production. If you've got, you can measure your generator, if you've got a diesel generator, and your HVAC and parts of your factory, and you can do it all on one device. And because you're doing it on one device, you can then look at what your loading is made up of. It's all very well going into a situation and looking at your main supply, but what is made up of your main supply and when are you using those loads? And this becomes very, very pertinent when it comes to specifying solar, rooftop solar, because if you're using your lights at night, it's no good putting it it's no good adding panels to cover your lighting, because you're not going to get solar at night anyway. So it's a very good system for specification. If you want to specify generators, if you want to measure subloads, and if you want to know what your full electrical reticulation system is doing. And there again, as I said, you can measure, and then at a later stage, if you want to, you can then go and add control in certain areas based on obviously the measurement that you get. I chatted briefly about the firmware updates. So there's no local maintenance required. There's no aging of the hardware. All the future innovations are incorporated through the firmware. And as I mentioned, the firmware updates actually 10 to 15 annually. And most of my clients don't even know that the firmware updates have been done. We update the app and the dashboard regularly. And if there's a big update on the app, you will see when you update your app, it'll come and say what's new, and it'll show you what's new and what's available on the app or the dashboard. So that's a very, very nice function, and there's no charge for that. As I mentioned, the energy data is free for the life of the product. Just on the communication modules, we chatted about the three. You can see the Wi-Fi Connect, it gives you energy measurements and Wi-Fi. It's 2.4 gigahertz Wi-Fi. The Smappee Connect gives you Wi-Fi and wired Ethernet and the energy measurements. And the Genius gives you control and load balancing, and it allows you to add all the extra modules. It's also got the internal MQTT broker. So if you want control and power quality and you want to add other modules, then the Genius would be what you needed. If you wanted data only, you could choose one of those two gateways. All the data is downloadable in CSV format as well. Plug and play. There's two ways. You do the physical installation in the distribution board, and then you configure the Smappee on the app or on the dashboard. So once the Smappee is physically installed, you would not have to go onto the Smappee to go and program it. You would go onto your app, and there's a wizard on your app which says, I've connected my grid, what size are the CTs on my grid, what's the maximum load on the grid, and which CT have I connected around L1, L2, and L3. And it's a very, very simple way of configuring the installation. As I mentioned earlier, 15 years in metering, you very, very, very seldom find broken meters. You find broken installations. 99% of incorrect readings on a meter are due to installation or configuration issues, not the actual meters. The new meters either work or they don't. They're not slow or they're not fast. That would be, if it was slow, it would be an installation issue or a configuration issue. If it was fast, it would be a configuration issue. So it's very, very easy to go through the installation wizard on the Smappee app and dashboard. When you walk away from the installation, the data is already coming through. You don't have to go somewhere else and connect to some system where you've got to go and find the data. Okay, so we do clip CTs and we do Rogowski coils. A really big value add is we can do remote configuration, and we can do remote first line support, and we can do remote maintenance. So if the installation is done incorrectly, we can actually fix it remotely, and you as a customer can fix it remotely. So if the CT is the wrong way around, the polarity is incorrect, you can go and change the CT on the app or on the dashboard. So you don't need to go back to site to correct the installation. We want people to go to site, do the installation, walk away, and you must be getting data and accurate data. If for some reason your contractor or whatever doesn't do the installation correctly, you can then go and remotely go and do the commissioning of that. And that is, I actually don't know of any other product around that you can do that. And that's one of the big pluses of the Smappee system, is fixing an installation remotely. You can go map a phase and you can go and change a CT. Size, very, very small. As you can see, iPhone 11, so it fits into pretty much any breaker panel you can find. So, and you can do multiple measurements in a very small space. A lot of the panels are getting smaller and smaller. Architects are giving people less and less space for electrical systems, and I've found that the Smappee is the go-to product in places where there is limited space and you would need to do multiple measurements. For instance, a petrol station, a gas station, those type of franchise like a McDonald's and those type of things as well, where you generally have got very small distribution boards. So the dashboard would give you real-time and historical data. It can give you energy, solar, gas, and water. It can give you all your sub-metered appliances. It'll give you your data across multiple sites. You can do your channel and your CT configuration. You can tailor your dashboard so you can make it look different. You can export everything as a CSV file. It's got a first-line support tool, and there's a possibility of adding your logo and your branding as well. So it's a comprehensive dashboard that gives you all the 99% of the electrical information need. The only software as a service would be is if you wanted maybe the power quality, the harmonics or the minimum maximums on the voltage and the current. But everything else is a basic user license, which is there. The app, also iOS and Android, 6 languages, real-time and historical data, also energy, solar, gas, water. We can connect through the IoT platforms. You can control your appliances remotely. You can control it manually, automatically. Your appliances, you've basically carry it around with you. It connects anywhere and you can see your energy usage. You create all the automations and your energy flows, and then there again, it's possibility to add logos and branding and things like that. The app also allows you to put tariffs in, so you can actually put energy, water, and gas tariffs in to give you a currency to tell you what it's actually costing you. Okay, the dashboard doesn't allow you to do that. The app does, though. And there, it'll tell you, if you choose a week, it'll tell you what the cost of your energy is over that week, or month, or year. Lastly, before I answer some questions, just a couple of use cases which I think you guys might be interested in. We did a project with Butterfly in the US. They actually got the contract to do all the subways in the US, so over 1,000 stores. So it's a very, very good product for the franchise type stores where you've got multiple stores all over the country or whatever. It works very, very well. So the installation is about 3 times faster than conventional metering. And as I mentioned, in that type of situation, the size is very, very important. It's a small product, small footprint. And that was one of the big reasons why they actually chose us. Okay. So we've got over 1,000 over 1,000 in the subways in the US. We've done a lot with the World Wildlife Fund, where they look at they're looking at obtaining the energy insights because they want to put solar panels on their offices, and they do the installation of the Smappee to then specify their solar, what they need, and then they leave the Smappee in afterwards, because then they can actually reduce the capital cost of their solar, because they can switch things on and off based on what's essential and non-essential loads. And that brings out a massive, massive saving. Not only a massive saving from a CapEx point of view, but also from an OpEx point of view. We did quite a large project at Schiphol Airport in the Outlook building, so the Microsoft building, where they were looking at car chargers. They had space on their electrical system for 14 chargers, but because of our dynamic load management, they actually installed 40 chargers, and then without having to actually upgrade the infrastructure. So a big problem worldwide is that the infrastructure is in, the utilities aren't allowing people to do upgrades on the infrastructure because there is just no more power really available, and the costs are quite prohibitive, especially in a smaller type industry. So what you do then is the guys would use the Smappee to install the equipment that they want, but then they can do the dynamic load management on the equipment. So you don't get nuisance tripping. You can maximize in this particular case, they maximize the charging station capacity. So they ended up putting 40 chargers in instead of 14. We've also, that's our building in Belgium. It's a CO2 neutral building. You can see the nice big battery there. It's a 2.5 megawatt battery. And we do full optimized self-consumption. We put energy back into the grid, so we actually get paid from the Flanders utility for what we put back in the grid using the Smappee. And we've got pretty much all the information that we need, and we do full load control, and we've got, I think, 22 car chargers. You can see there are 2 big ones over there, and there's another 18, I think, 18 or 20 in the middle here. So it's a full smart building with a 2.5 megawatt battery, solar panels on the roof, and we export back into the grid in Belgium. Couple of other use cases. I've mentioned self-consumption, optimized self-consumption. So when you are producing solar, use the solar that you are producing. You've paid for the capital expenditure. It's absolute waste if you're producing 10 kilowatts of solar and you're only using 5. Obviously, there's energy cost savings. So you measure first, and then you do your switching of non-essential appliances. You can do that based on different tariffs. So when if you've got a multiple tariff structure, you can do that with a cheaper tariff. Dynamic load balancing, I've gone through. Smart EV charging. We do control over HVAC systems. As you know, I think 48% of worldwide electricity consumption is heating and cooling. Big thing to go and look at in commercial industrial buildings. Renewable energy specifications, so to go and specify your solar systems. We can make meters intelligent by connecting them to the Smappee cloud. Very cost efficient and accurate load measurement. I see there is a question about the accuracy. I will answer that question. I do a lot of grid monitoring with utilities where they do mini sub monitoring, where they want to see where their loads are going to, what their phases are, the balance, the imbalance of the phases. We can prioritize usage of compliance, overload protection to stop breakers tripping. And then in some countries, you can do smart grid exchange where you actually produce your excess solar, whatever goes into the grid. Okay. Yeah, so that's just an overview of the Smappee system and how the energy management works. I see there are a couple of questions. Maybe let me just go to the chat quickly. Sorry, I'm just going to have a look here. So I see, can a solution through import-export be connected with a PD system to control, use it as a zero export? Yes, it can. So you can say, when I've got excess solar, I must close a contactor and I'm not allowed to export back into the grid. A lot of people do that using their actual inverters, but yes, it can be used to do a zero export. What's preferred is that you actually, when you've got excess solar, switch things on. So cool my house down. If you're I know in the Middle East, a lot of the ACs run all the time. Put my water heater on, and do that type of stuff. So you're actually using the full PV system. Okay, so the accuracy of the CTs. So the overall accuracy of the system is 1% or better. So it's a class 1 system. Okay, the CTs, if I just can go back, I think I should be able to go back here. I just want to show you quickly. There. Okay, so the split core CTs like this are actually class 0.5. The Rogowski coils are class 2. We don't get better in a Rogowski coil, unfortunately. And the solid core CTAs are class 0.2, so it's 0.2%. The overall accuracy of our system is 1% or better. And the reason for that is this CT hub here, where you connect your CTs into it, that's a smart device, and it's got a correction factor into it. Okay, so I hope that answers that question. I have got a document on the accuracy. We've tested it on a certified test bench. So yeah, I have got that document. Can I connect all Smappee devices to only one Genius device, and what is the maximum allowed distance? Okay, so very simply, I'm going to go back to my other slide here. Sorry guys, I'll be there. That slide there. So the power box, the last current transformer can be 100 meters away from the power box. And the Genius can be 100 meters away from the power box. So this is an RS485 bus, and it's a powered 485, so you can have 100 meters away. We have got an option of doing multiple gateways connected to one Genius. So if you had a system where you've got maybe 4 incomers, 4 mini subs in a place, and you want to measure all the mini subs under one location, you could put a Smappee in each mini sub, and then you would put a Genius, which acts as your building energy management system or your factory energy management system. So there is that option as well. The other option that we have got in here, you can actually add the Smappee MID meter, and that will then, it counts as 3 current transformers because it's a 3-phase meter, and you can then use that as a DIN rail 100 amp direct meter as well. So there's quite a lot of ways of putting a Smappee together. So yeah, 100 meters from the last CT to the power box, and the gateways can be 100 meters away from the power box as well. Okay. All right, guys. Yeah, I don't know if there are any other questions that people want to ask. That's just the stuff on the chat. If there's anything else.
Thank you, Nigel, for this informative session. I really enjoyed it. I think there is another question.
Yeah, so no, we don't support DLMS. We are Modbus. So our protocol is Modbus.